Okay, pause and copy everything that's new here. Okay, so we have a nice little pattern to follow. If you're doing some integral and you see something that looks like this, which we just did, we had 1 squared minus x squared, then you should try this substitution and make use of this identity. Okay, similarly, you have some thingamabobs that correspond to these thingamabobs, and then you thingamajig. Yeah, right. Less talking, more teaching. Let's do an example. Which one is this? It falls into this category, right? So I should use this substitution. What is a? Be careful, a squared. This is a squared here. So a is equal to 3. So d is an a. A is equal to 3 here, because 9 is a squared. So I try x is equal to 3 sine theta using this formula. So as above, you can find dx d theta, and then the d theta ends up over here. And then you plug in these two pieces of information into your original integral to arrive at this thing. So pause and copy all that. I gave you some details on what happened to the square root here, which is often the messiest bit. Now I'll take a chance to simplify everything. Okay, very important in integrations. Simplify before you cry. Simplify before you cry. I should get that written on a t-shirt or something. So I got cos squared over sine squared. What to do, what to do, what to do. Well, I say, well, this is just cotangent squared, right? Because cotangent theta is cosine of theta over sine theta. Okay, once again, I have something memorized, which helps me in my time of need. My hero. So cotangent squared. So why am I happy with that? Well, cotangent squared, cotangent squared. Well, I'm not happy with cotangent squared on its own, but because cotangent squared can be related to cosecant squared, I am a happy camper. Okay, cosecant squared, the integral of that is something that I have memorized. So I make the conversion. So again, I use a trig identity here, and then integrate term by term. Now I'm in a position again where I have to convert back to x. So form a triangle and work things out. So pause and copy. So again, you use, to find this side length here, you'll use Pythagoras, and you'll get 9 minus x squared via Pythagoras. Let's write Pythag here. So I used Pythag to get that. The x and the 3 were given when I solved for sine theta here. And as before, I have my theta is the arcsine, and cotangent theta is, what is cotangent theta? Well, I always forget. What is cotangent? Tan theta. So this is what goes from my tan theta, TOA, opposite over, adjacent. So now I can remember that cotangent is the reciprocal, adjacent over opposite. So the adjacent is the square root dude here, and the opposite is my x. Mm, 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 mm. Oh yeah, it's squared there. I don't believe it should be squared. Cotangent is cotangent squared. No, I don't think it should be squared. What am I doing here? Huh. That's peculiar. I seem to have found a little boo-boo. You know what? Let's just see. Let's just grind ahead here, and I'll let you copy all that down. And then we'll come back and see if I can't resolve my difficulty in the next video.